Hi everyone, welcome. We'll be going through an overview of the Earth's magnetic field and its impact on our nice blue and green planet today. There are four big questions we want to answer. First, what is the magnetic field and how do we know it's there? Second, what does the magnetic field do for the planet? Third, does it change? And finally, where does it come from? So, I guess let's just go right into it. So in the most simplified manner, the Earth acts as if it has a giant bar magnet inside of it that produces the magnetic field. The magnetic field is visualized as lines of equal magnetic strength that originate from the Earth's southern pole and travel through and around the planet to its northern pole. What this means is that actually the North Geographic Pole is a S magnetic pole, and the South Geographic Pole is actually an in magnetic pole. Unlike Earth gravity, where the direction of motion is always towards the center of the Earth, the magnetic field acts differently on different particles. This depends on their electromagnetic properties. If material is strongly magnetic, like iron for example, the opposite poles attract each other, and the material will align itself with the magnetic field lines and then potentially move along them. If the particle has an electrical charge, it just ends up going in a circle. This is an important result we'll come back to later. Taking advantage of the fact that magnetic minerals align themselves with the magnetic field, humans invented compasses. The first compasses on record are from China from around 2,000 years ago. Around 800 years ago, they spread to the Western world and began to look like they do today. They have a needle and a bubble. More recently, though, compasses have completely changed their form and now exist in everyone's pocket, such as my phone. Compasses point toward the north, but it's actually a bit more complicated than that. Compasses actually point towards the magnetic North Pole, which we now know is Earth's S magnetic pole. It's located very near the geographic North Pole, so it's good enough most of the time. The magnetic field of the Earth protects the surface from charged particles that are released from the sun. These particles form the solar wind and have the potential to disrupt and create holes in the Earth's ozone layer and disrupt electronic systems if they penetrate into the atmosphere. The image you see here shows how the magnetic field extends far beyond the Earth, creating the magnetosphere. However, it is compressed in the direction of the sun because of the solar wind. Since the compression is not complete, we know there is some point at which the pressure equalizes. That is called standoff distance. Solar wind is made of plasma at temperatures of 1 million degrees Celsius. These particles, primarily electrons and protons, shoot out from the sun at speeds of over 3,000 kilometers per hour. When these particles hit the magnetosphere, their charge means that they begin to change their direction, which is good, because it means they're directed away from the Earth's atmosphere, and the electronics on the planet and the ozone layer are protected. However, since the magnetosphere merely redirects the particles, it doesn't act like a true wall against the solar wind. This means that changes in the magnetosphere also cause changes in its ability to shield the atmosphere. Earth's magnetic field is constantly changing, but day-to-day changes are relatively minor. Most changes are only noticeable after a few years to a decade. We have extensive knowledge of the magnetic field over the last couple decades, thanks to satellite data from the Eostel and Swarm satellites. Ground-based observatories like those in France or Hawaii have been providing data for over a century. And in addition, scientists have been able to use compass data from shipping records to extend the data set to nearly 400 years. So now the magnetic field exists, and we can measure and study how it changes. But the question remains, where does it come from? And the shortest answer to this is just from the Earth itself. Inside, the Earth is broken up into layers: the crust, the mantle, and the core. The crust and the mantle are made of various types of rocks, but the core is different. It's made of an iron-nickel alloy. The core is then itself split into two parts: a liquid outer core and a solid inner core. This liquid iron alloy in turn moves around the core as the Earth spins, just like water moving in a glass. But since iron conducts electricity, these liquid currents actually generate an electric current as well. This massive electric current in turn creates a magnetic field we measure today. Now, we can cycle back because we have answers to today's questions. What is the magnetic field, and how do we know it's there? The magnetic field encompasses the Earth and is what compasses use to determine magnetic north. What does the magnetic field do for the planet? The magnetic field protects the Earth from the charged particles in solar wind. Does it change? Yes. It changes continuously, but most changes are only noticeable after about a few years. And finally, where does it come from? It comes from the circulating molten nickel-iron alloy in the Earth's outer core. Thank you for joining us today, and please like and subscribe.